There you go. Okay, so 4.3. This time we want to see how does a fraction will be, or rather, how does a fraction look like? That means a rational function. We will try to work on those. Previously, we have worked on functions in the form of polynomial, power, etc., etc. But this time, we'll try to work on rational functions. Okay, so first of all, how does a rational function look like? So we want to see the general formation. So the rational function looks like this. Okay, where we'll have actually two different parts. This one is called numerator, this one is called denominator. You guys know that from Math 95 or 6 or even before that. Okay, and this can't be 0. Okay, this function can't be 0 because if it's 0, then the entire function will be undefined. So that doesn't make any sense. Okay, and ideally, or you can always define this way, that each of these a's and b's will be polynomials. Of course, it will be different polynomials. Okay, it won't be exactly the same, because otherwise you can cancel these two, and in result you will get 1. That doesn't make sense either. That doesn't keep it a rational function. That doesn't maintain the property of rational function. Okay, so it will have two different polynomial. So you have it as equals 0, but you mean it not equal 0. Well, I said it can't be 0. Yeah, that's right. I said it can't be 0. So let me write it this way, so that when you see that PDF again later tonight, you might not get confused. Yeah. Okay. So that's how a rational function look like. Now we want to see how does, or rather, how can we calculate the domain of a rational function? How can we calculate the domain of a fraction or a rational function? So fortunately, I think we have discussed this before, how to calculate the domain of a fraction. So who can give me just a brief idea of this, regarding this? I can remember I have already discussed this before. If you have a fraction, how can we find the domain of that without looking at the PPTX file? Can anyone give me an idea? How can we calculate the domain probably? No one? Okay, no problem. We can always go back and try to remember those. Anyway, so whenever you have a fraction, let's say f of x equals ax over bx, whenever you have a fraction like this or a rational function of this format, all you want is the values of x, not b of x, values of x, which is making b of x 0. That means the values of x for which b of x will be 0. We actually try to look for those values of the given variable. On this occasion, it's x, so you need to find the values of x for which your denominator becomes 0. And apart from those values, everything else will be your domain. So we'll actually exclude those values for which the denominator becomes 0. And apart from those, we'll say everything else is our domain. Okay, so let's quickly try one or two examples. I'll try one first, and then I'll give one to practice, and then you can give me the idea. Okay. So let me try this. Okay, let's start with an easier one. Okay, let's try this. So if I have a rational function, first of all, we want to set this to 0 and see what's the value of x, or if I have multiple answers, what are the values of x which is making this 0. So we need to set this to 0 and solve it for x. So x equals 5. So that means whenever x is 5, the denominator is 0. And as I said, we'll actually exclude that and take everything else from the set of real numbers and say that this is our domain. So that means on this occasion, apart from this 5, everything is our domain. So we'll say our domain of this function, let's say, let me write y here because I have defined that function as y. So the domain is x, all of those x, such that the x is in real number. Okay, that means from negative infinity to infinity, where, or I might say, and x is not 5. So I'd say x not equal to 5. So that's my domain. So this clearly indicates that you are not taking 5, but everything else is your domain. And if you want to write using interval sign, we can start from negative infinity. We can't really take 5, so we'll go up to 5. We'll stop there, we'll not include it. In MML, would we write it like that with ENR? What do you mean by ENR? I didn't get that. Oh, okay, okay. So do you mean this? Okay, so okay, so no, you don't need to write that, because first of all, if you have multiple choice question, there is no question of writing. But if you need to write somewhere, then the first thing you need to check whether it's looking for the set or the interval. You need to take care of this. You have two different answers, okay? So if it says that write using the set notation, then you need to write this. Although you can avoid this, you can just write x such that x not equals 5. That's okay. But only if it says write using the set notations. But if it says write using intervals, then if you write like this, you'll get penalized, okay? So if it says write using interval signs, then you need to go for this. We are not finished though. There's still work to done here. So we have come from negative infinity to 5, but we can always go up to infinity starting from 5. As you can see, we're not really including this 5. In MyMATLAB, you can use a comma, but the right way to the mathematical way, I'd say, is this, using union sign. That means you are actually connecting these two intervals. Okay, this union sign means rather that you are trying to connect these two different intervals. Okay, any question from this? This is a kind of review what we have done before. Okay, no question. So what you can do is you can try this example, not now, after we finish. Let's try this x5, and let's say x minus 3, x plus 2. Try and find the domain of this, but not now, after we finish. But now we'll actually go to okay, so if we don't put the union sign on MyMathLab, but we put a comma, will it be considered incorrect? As I said, in MyMathLab, I have seen in my previous teaching experience, they generally accept a comma, but I don't know, it might have updated its policy, so you need to check. So again, if you use union, there is no question that you will be penalized, so you can always use the union sign to be on the safer side. I'd recommend you guys to do that. But in my previous teaching experience, I've seen that students have put comma and got full credits on that. But again, I don't recommend that, because that's not how we mathematicians write, right? So we want to use union instead. Anyway, so go through the example 3 on 4.3, example 3 on 4.3 PPTX on the resources that's been given. I'm not going to show that because I've already shown problems like that. That's using transformations to graph rational functions. So there you will see using this, you need to graph x plus 1. Oops, sorry. X plus 1, the quantity squared minus 2. We're doing 4.3 all class tomorrow. Yeah, again, as I said, as per the schedule, we have 4.3 tomorrow, right? Is that right, Pearson? Yes, yeah. So that's why I said go through this example first, example 3 from 4.3. We'll obviously go and dig deep into 4.3. We'll try to understand a difficult concept. I wouldn't say difficult, but it's not that easy. The concept of asymptotes, we'll try to see how does that look like, how can we calculate, how can we do blah, blah, blah. But before that, I want you guys to go and see the examples from 4.3, because again, I'm repeating myself, this will give you an idea what we are going to see, and it will also create some questions on you. That's really important as well. If you have questions in your mind, that means two things. That first of all, you have you have gone through the topic, you have tried to read the topics, and of course that means you are on the right track to learn. Okay, so I'd really inspire you guys to go through the content just before we start the discussion. So yeah, of course we'll see more examples tomorrow, especially on asymptotes. I'll try to give you some inside stories, some shortcuts as well. I'm not sure whether they have the shortcuts here. Let me have a quick look. Doesn't matter if they have or not. I'll give you some shortcuts on that so that you can save time as well. But of course, we'll know the explicit way to calculate or find asymptotes as well. So we'll spend time on that. But yeah, of course, first of all, try and get an idea from 4.3. Okay. Okay, so what I can do, okay, let me do this way. Let me actually show you the graph of this. Okay, and we'll actually keep the asymptotes for tomorrow. Are you guys okay with that? what we can do, we can actually discuss this, and I think we can keep the asymptotes for tomorrow, because that's difficult. So if you try and go through that tonight, and then we can discuss that tomorrow, this will be easier for you guys to understand what I'm saying. I think that should be a good idea. Okay, so let me do this way. So let's try example 3. Y equals 1 over x squared. So first of all, it's really important to know how does this look like, but for now, let's assume that you don't know that, okay? I'll draw that for you, okay? So first of all, a +1 question. Whoever answers first will get a +1, of course. Y equals 1 over x squared is even or odd? Is it even or odd? Even, anyone else? Even. Okay, so I guess Daria got it right first, although even is the right answer, but I can only give the person who answers it first. So you get a +1. If I don't add +1 to your quiz in quiz 3, you can always send me a reminder, okay? Is there anyone who hasn't got a +1 whom I promised to give? I guess most of you got a full credit, so I didn't have a chance to add that one, especially on quiz 1. The guys got +1 actually got 100%, so there's no way I can add +1 to that. So anyway, so let's move on. So we have even function, because simply, let me show it this way. If we try negative x squared, we still get positive x squared, which is f of x. That means it's an even function. Now, what does that mean? An even function means it's symmetric with respect to the y-axis, right? Do you remember? If it's even, then it's symmetric to the y-axis, right? Okay. Now, as it has a positive, I wouldn't say positive, but I definitely say it's an even integer here. That means that the entire function will be above the x-axis. Can you see that? We don't have any other terms associated with it. So you can clearly say, as this is an even exponent, the entire graph will be actually above the x-axis. Can you see that? Okay. Now, we want to graph it. So the best way is to find the x and y intercepts, but if you're clever enough, you can see you can't really find any x and y intercepts from this. Can you see that? Because if you plug in y equals 0, then 1 over x squared is 0, right? So that doesn't really make any sense. If you plug in x equals 0, then it's 1 over 0 squared. It doesn't really make any sense either. Okay, so there is no real x and y intercepts here. Can you see that? And tomorrow you will see that we can have a certain line like this, where your graph will approach to, but it will never cross that, and we say that as asymptotes. You know, your graph will actually approach that, it will go very close to that, but it will never cross that, or not even touch that. We say that asymptotes. And here for this example, let me just say that to you, that x equals 0 and x equals y, these two are actually your asymptotes for this graph. Okay, I will discuss it tomorrow, no worries. We'll not go there today. But today, only thing we already know that there will be no x and y intercepts. Okay, now how can we graph it then? Then we definitely know one or two things, that if we plug in different values of x, in return we'll get different values of y, and we can plot those points, and if we add those, we'll get our graph, right? So let's quickly do that. If I plug in x equals 1, y will be 1. If we plug in x equals 2, y will be 1/4. If we plug in x equals half, y will be 4. Same goes for -2. Same goes for -half. So if we just plot these points, 1, 1, 2, 1, 4, oops, sorry, 2, 1/4, half 4 to -2, 1/4, and -half 4. If we plot these 5 points, and if we join these points, we'll get our graph. So let's do that. Let me use this smaller portion so that we don't need to scroll down. So for 1, it will be 1. For 2, it will be 1/4. So it will be somewhere here. Okay. For half, it will be 4, somewhere here. So this graph will go like this, and on the left hand side it will go like this as well. So clearly our graph will look like this. Okay, so that's the graph for y equals 1/x², and I'd recommend you guys to remember this figure. Okay, that's one of the core graphs as well, because in your tests and quizzes, if you know this graph, we'll be able to transform graphs using the concept. Although I'd really like you to, I would really like to give this graph as a hint, but I'm not sure whether I'll be able to do that in all the cases. So I recommend you guys to remember this. How does this calculation? Okay, so your y is 1/x², right? So just plug in 1 here. 1/1² is 1, right? Plug in 2 here. 1/2² is 1/4, right? Does that make sense? Yeah, cool. Okay, so now, as you know, the graph of y equals 1/x². Now, excuse me. Now, we want to graph using the concept. We want to graph this. Let's try this one first. Okay, let's try this one first. We won't try the graph for this one today, because this actually requires you to know the concept of asymptotes. Okay, so I'd rather keep it for tomorrow. I can show that today. There is no harm in that, but I think if you know the concept of asymptotes first, this will make more sense to you guys. Okay, so let's try this. So can you graph this? Anyone? Does the -2 indicate a shift up? Well, -2 in general doesn't shift up. It actually shifts you down, right? Yeah, I understand. I got it. So now, if you just shift, if you're trying to shift it, what happens? So first of all, we know that in general, this -2 means our graph will go down by 2 units, right? And fortunately, that's true for fractions or rational functions as well. Yeah, you got it right. It still uh, makes your graph go down by 2 units. Yeah. So what it means that instead of looking like this, let me quickly draw the main graph for you. Instead of looking like this, it will actually go down by 2 units. So let's say that's my y equals -2. So now this graph will actually look like this. Okay. Any question from this? You can take your time. Anyone, any question from this? Oh, well, if you have a problem like this, now you can rather calculate x-intercepts, excuse me, simply because you can see we have an additional term here. So if I plug in y equals 0, then can you hear me now? Okay, okay, yeah, cool. Okay, so uh, now as you can see that we have an additional term here. We can actually calculate the x-intercept, which is half 0 and -half 0, right? But we don't need to do that, simply because um, we want to use the graph of 1 over x squared and make these transformations. We don't need to, we don't want to calculate, we don't want to go for explicit calculations for this graph. Rather, we want to use this graph and make the transformation. Yeah. Okay, any other question from this? No one? Can you hear me now? Okay, yeah, cool. I don't know what happened. Anyway, so that's it for today.